Assalamualaikum and hello everyone. So today in this video, we are going to continue and learn more about the application of differentiation, which today we focus on the maximum and minimum problems. So as you know, we have already learned about what is the differentiation, how to solve it by using various of technique or formulas, how it is very useful to us for solving a real life problem, and today we are going to see what differentiation can tell us more about a function. At the end of this lesson, you should be able to apply the differentiation technique in finding the maximum and minimum values. So for now, let's just get some practice in finding these values. Let's say we have a function look like this. We can actually and easily eyeball on the graph and we can tell that there is a maximum and minimum points. Did you know that the derivatives are very useful and can help us on finding where those are exactly? Let us recall back what we have learned before. A derivative can also be interpreted as the slope of a tangent line, and the tangent line at any maximum or minimum must be perfectly horizontal. Then the derivative of a function at any of these points must equal to 0. So in order to find them, all we need to do is actually take the derivative and find the zeros of the derivative, that is f prime x is equal to 0. So therefore, to find a point at which the graph has a horizontal tangent line, we need to find the derivative and set it equal to 0, because that's when a slope of the curve will be 0. And then we need to solve for x, which are known as critical values. So here we got C1 and C2 as the critical values. Now let's look at another example. Consider the graph of a continuous function f in the figure shown. Let's say I label some of the points as C1, C2, C3 up to C8. Now, let's figure out at which of these points of C has a horizontal tangent line. As we observe, the tangent line is horizontal at C1, C2, C4, C7, and C8. However, it is obvious that at C3, the tangent line is not horizontal, as it is vertical. And at C5 and C6, these are called as a corner points. The f prime or the derivative are undefined here. So f prime c is equal to 0 at C1, C2, C4, C7, and C8, which those are critical values, while f prime c does not exist or undefined at C3, C5, and C6. So what's critical values basically? So we let x is equal to c is a critical value of a function of fx if fc exists and if either f prime c is equal to 0. A critical point is a point where c is the critical values. So basically here, to get the critical point, when we get the critical value, we have to substitute back into the function to get the y values. Let's go for example 1. Find the critical values for the function fx is equal to x cubed minus 5x squared plus 3x plus 2. So let's begin with the first derivative. It is known as a critical value when f prime x is equal to 0. So the first derivative of this function will be 3x squared minus 10x plus 3 is equal to 0. And then we have to factorize. We will get in bracket 3x minus 1 in bracket x minus 3 is equal to 0. So by calculus, we can separate 3x minus 1 equal to 0 and x minus 3 is equal to 0. Then we solve it as x is equal to 1/3 and x is equal to 3. So these are the critical values. Example 2. Find the stationary points for the function of fx is equal to 3x to the power of 4 plus 16x cubed plus 24x squared plus 3. For your information, stationary points are also called as critical points. So in order to solve this question, we must first do the first derivative. So the derivative of 3x to the power of 4 will get 12x cubed The derivative of 16x cubed, we will get 48x squared. The derivative of 24x squared, we will get 48x. And the derivative of constant 3, we will get 0. And then we need to find the critical value by satisfying f prime x is equal to 0, and then we'll get 12x cubed plus 48x squared plus 48. We factorize 12x, we will get 12x in bracket x squared plus 4x plus 4 is equal to 0. In this bracket, we also can factorize again. We will get 12x in bracket x plus 2 square is equal to 0. By calculus, we can solve x values, and we now get the x value as 0 and -2. These are the critical values, but the question wants the stationary point. So we need to substitute all the critical value inside the function of fx. So at x is equal to -2, so we'll get fx as 19. As x is equal to 0, we'll get fx is equal to 3. So this stationary point we will get as -2, 19, and 0, 3. Now we are going to learn about how the derivative can actually tell us whether the fx is increasing or decreasing at certain interval. Before we proceed to the question, let us check this condition or understand it. If f prime x is greater than 0, then fx is increasing. But if f prime x is less than 0, then fx is known as decreasing. Let's go for example 3. Find the interval increase and decrease for the function of fx is equal to x cubed minus 6x squared plus 9x. Okay, first step, you need to find the first derivative and then equal it by 0. So here we will get f prime x is equal to 3x squared minus 12x plus 9. And then to get the critical values, we need to equal the f prime x is equal to 0. And then we will get 3x squared minus 12x plus 9 is equal to 0. By factorizing and then solving the x value, we will get x is equal to 1 and 3. So these are the critical values. Step number 2, we have to arrange these critical values in ascending order and partition the domain of fx into various intervals using the critical values. So in this case, we have to partition it into 3 different open intervals. So let's start with the left-hand side first. As we can see, at this interval, we can say it as open interval of -infinity up to 1. At the middle here, we will get open interval of 1 up to 3. And at the right-hand side here, we will get open interval of 3 up to positive infinity. Now, the step number 3, we have to check the sign of f prime x in each open interval and then identify whether the function is increasing or decreasing. So, first we need to choose any number or any value within the interval given. Okay, so that we can substitute the test value inside the f prime x in order to get the sign of f prime x. So, let's say at this interval of -infinity up to 1, let's say the test value is 0. So we have to substitute at f prime x. So we will get 3 in bracket 0 square minus 12 in bracket 0 plus 9. So it is obvious that we get positive 9. So the sign of f prime x at this interval is positive value. So at this interval, it is known as increasing function. So let's move in the middle interval. So at the middle here is 1 up to 3. So the test value, let's say, is 2. So substitute 2 into the f prime x, we will get the sign of f prime x equal to negative value. So this interval has decreasing function. Okay, for the last interval, open interval of 3 up to positive infinity. Okay, let's say we take 4 as the test value and substitute into the f prime x. Then we calculate it, then we get the value as positive value. So we know that this interval is increasing. So as a conclusion here, we'll get fx increase in the interval of -infinity up to 1 union with 3 up to positive infinity, while fx is decreased in the interval of 1 up to 3. Example 4. Determine the value of x when the function fx is equal to x power of 4 minus 2x squared is increased and decreased. Okay, so this example 4 is pretty similar like example 3. The first step is need to find the first derivative, and then we need to solve it by satisfying the condition of f prime x is equal to 0. So we will get 4x cubed minus 4x is equal to 0. Factor out for x, will get 4x x squared minus 1 is equal to 0. Then we factorize again, we will get 4x in bracket x minus 1 in bracket x plus 1 is equal to 0. So here, basically we have three critical values. So we get x such that x is equal to negative 1, 0, and 1. Okay, so since that we have three critical values, the next step is that we have to check the sign of f prime x in the immediate neighborhood of each critical value. So since that we have three critical points, so we need to partition it into 4 different open intervals, such that negative infinity up to negative 1, negative 1 up to 0, 0 up to 1, and 1 up to positive infinity. So at this each open interval, we have to choose any test value to substitute into f prime x to get the sign of the value. Okay, so for the first interval here, let's say we take negative 2 as the test value. So substitute into f prime x, we will get negative value. So here at this interval is decreasing. So at the next interval of negative 1 up to 0, let's say the test value is negative 0.5. Substitute into f prime x, we will get positive value. So it is increasing at this interval. Moving on to the next interval, which is 0 up to 1, the test value is 0.5. Substitute into f prime x, we will get negative value. So here will be decreasing function again. So moving on to the last interval, which is 1 up to positive infinity. So the test value, let's say is 2, then substitute back f into f prime x, will we get the sign positive value. So here will be increasing value, increasing function again. So as a conclusion, we can make as fx is increased in the interval of negative 1 up to 0 union with 1 up to positive infinity, and fx also decrease in the interval of negative infinity up to negative 1 union with 0 up to 1. Okay, now what is extremum points and how to get it? Extremum point is actually any point at which the value of a function is largest or smallest. Largest means it is a maximum, and smallest mean that there is a minimum. So as you can see at the figure shown, there is a maximum point and also there is a minimum point there. Example 5. Determine the extremum point for the function of fx is equal to x cubed plus 3x squared minus 9x minus 13. So the first step, like as usual, you need to find the f prime x. So we get 3x squared plus 6x minus 9. And we have to satisfy the condition of f prime x equal to 0. So we get to factorize the function of the derivative. Then we get x plus 3 in bracket x minus 1 is equal to 0. Separate it, we'll get x plus 3 equal to 0, x minus 1 equal to 0. So we'll get the value of x is equal to negative 3 and x is equal to 1. So we get this critical value as negative 3 and 1. So we have then to check the sign of f prime x in the immediate neighborhood for each critical values. So we have to make the partition. So we will get negative infinity up to negative 3, negative 3 up to 1, and 1 up to positive infinity. So for each of open interval, we need to have a test value. So we have to substitute back into the f prime x. Okay, for the first interval, we'll get positive value. And then for the second interval, we'll get negative value. And the last interval, we will get positive value. Okay, so if we draw the function, we know that it is increasing at the interval of negative infinity up to negative 3. and then it decreasing at the moment it reach of the interval of -3 up to 1. So at the interval of 1 up to positive infinity, it is increasing again. So as we can see, there is a maximum point at -3, and also there is a minimum point at x is equal to 1. So at maximum point, we can actually get by substituting x is equal to -3 into fx, then we get y value as y is equal to 14. So the maximum point is actually -3, 14. For the minimum point is at when x is equal to 1. So we get the y value as we substitute, we get -18. So the coordinate of minimum point will get 1, -18. So the maximum point and the minimum point here is the extremum point. Okay, now how do you want to know whether fx is concave upwards or concave downwards at certain interval? So now let's look at this condition. If f double prime x is greater than 0, then fx is concave up. Otherwise, if f double prime x is less than 0, then fx is known as concave down. So here it is obvious that we need to make the second derivative after the first derivative. Fx is concave up on an interval if all of the tangent to the curve are below the graph of fx. And fx is concave down on an interval if all of the tangent to the curve are above the graph of fx. What is the inflection point? At point x is equal to c is called an inflection point if the function is continuous at the point and the concavity of the graph changes at that point. Example 6. Given fx is equal to 2x cubed plus 6x squared plus 3x minus 4. Determine the interval of concavity and inflection point. So in this question, we have to differentiate twice. So we have to make the first derivative first. So we get 6x squared plus 12x plus 3. So f double prime x will get 12x plus 12. So in order to find the concavity and also inflection point, we have to satisfy the condition where f double prime x is equal to 0. And solve the x value, then we will get x is equal to -1. The next step is that we have to make the partition of -1 into two interval here, which is -infinity up to -1 and also -1 up to positive infinity. So, and then we have to substitute the test value inside the f double prime x in order to determine whether it's concave up or concave down. Okay, so substitute the test value here. Let's say it -2 for interval of -infinity up to -1. So substitute the value, we will get a negative value. So at this interval, we know that it is concave down as the sign of the f double prime x is equal to negative value. So at the next interval here, let's say the test value is 0. Substitute into f double prime x, so we will get the positive value. So at this interval, we know that it is a concave upwards. So as a conclusion, we know concave up is equal to -1 up to positive infinity. Concave down is equal to negative infinity up to -1. Okay, it is obvious that by looking at the figure shown, the inflection point is when x is equal to -1. So to find the y value, we need to substitute x inside fx. So we'll get the y value as y is equal to -3. So the coordinate point of inflection, we will get -1, -3. Now let's do the final example. Determine if any of the critical points for fx. So let's revise back how to get critical point. We need to find the first derivative and then equal to 0. And then we get 6x squared plus 18x plus 12 equal to 0. We will get x squared plus 3x plus 2 as we factor out 6. And then we factorize again, we'll get x plus 2 in bracket x plus 1 is equal to 0. Solve all the value of x, we will get x is equal to negative 2 and x is equal to negative 1. So the critical points, we have to substitute all the critical value inside fx. So we will get the critical point as negative 1, negative 3 and negative 2, negative 2. Okay, 7b, the interval where fx is increasing and decreasing and also finding the extremum point. Okay, for this question B and C, since that we already know the f prime x and also the critical values, we are now need to make the partition of these critical values into 3 different open interval. So we get the intervals of negative infinity up to negative 2, negative 2 up to negative 1, and also negative 1 up to positive infinity. Okay, so at each open interval, we need to have a test value to substitute inside the f prime x to get the sign or whether it is positive or negative. Okay, let's say the first interval, the test value is negative 3. So the sign f prime x will get positive value. So we know that this interval is increasing. So at the middle interval here, the test value is negative 1.5. So we'll get the sign of f prime x as negative value. So we know that negative value means that it is decreasing function. At the final interval here, let's say the test value is 0. Substitute into f prime x, we'll get the sign as positive value. So here is an increasing function. As a conclusion, fx increased in the interval of negative infinity up to negative 2, union with negative 1 up to positive infinity, while fx is decreased in the interval of negative 2, negative 1. Okay, how about the extremum points? So, like we have learned before, okay, we have to sketch or draw the diagram to see where is the maximum and minimum point are located. So it is obvious in the figure shown, the maximum point is when x is equal to negative 2 and there is a minimum point as x is equal to negative 1. So to get the points, actually we need to substitute all the point, which is the maximum point, x is equal to negative 2. Okay, substitute x into fx, so we'll get y value as negative 2. So the coordinate of maximum point, we will get negative 2, negative 2. So the minimum point is when x is equal to negative 1. So substitute x is equal to negative 1 into fx, so we'll get y value as negative 3. So we'll get coordinate of minimum point of negative 1, negative 3. Okay, example 7D and E. In finding the interval of concavity and also the inflection point. So at these two questions, actually we need to differentiate again from the first derivative. So we get f double prime x as 12x plus 18. So we have to satisfy the condition of f double prime x is equal to 0. We will get 12x plus 18 is equal to 0. Solving the x value, we will get x is equal to negative 3 over 2. And then we have to make the partition like this. So we will get the interval of negative infinity up to negative 3 over 2. And also the interval of negative 3 over 2 up to positive infinity. So like previous, we also have to make a test value to substitute into f double prime x. So let's say at the first interval, the test value is negative 2. Substitute into f double prime x, we'll get negative value. And then the test value for the second interval is 0. So the sign f double prime x will get positive value. Okay, so we know that it is concave down at the first interval and concave up at the second interval. And we always have to note that as sign f double prime x is equal to negative value, so it means that it's concave down. If the sign of f double prime x is equal to positive value or greater than 0, it means that it concave up. So, as a conclusion, concave up is equal to negative 3 over 2 up to positive infinity. And concave down is equal to negative infinity up to negative 3 over 2. And then it is obvious that in the figure shown, we can see that the inflection point occur at x is equal to negative 3 over 2. So to get y value, actually we need to substitute x value inside fx. So we get the y is equal to negative 5 over 2. So the coordinate or point of inflection we get as negative 3 over 2, negative 5 over 2. Okay guys, before we end our lesson, let us review and also do some summary the steps to be taken in order to solve minimum and maximum problems. Okay, the first thing is how to get maximum point. There are several steps need to be taken, which is the first, we need to solve x which satisfies f prime x is equal to 0. So we know that as we solve x is also known as the critical values. Step number 2, we have to arrange these critical values and partition it into intervals. Step number 3, we have to check sign for f prime x in each open interval. Step number 4, we have to check f prime x. So if f prime x is greater than 0 in a particular interval, then the function is increasing. Otherwise, if f prime x is less than 0 in a particular interval, then the function is decreasing on that particular interval. And last step is actually need to find the maximum point and minimum point by substituting x inside the fx function. Okay, then how about we want to find or to get the inflection point? The first step is that we want to solve x which satisfies f double prime x is equal to 0. And then we have to arrange x values and partition it into intervals. And then step number 3, check sign for f double prime x in each open interval. Step number 4, we have to check if f double prime x greater than 0, then fx is concave up. Otherwise, fx is concave down. And then last but not least, to find the inflection point, we have to find where is the function is continuous at the point and the concavity of the graph changes at that point. And then we have to substitute that x values inside fx, so we get inflection point.